Hello, Spring One. My name is Michael Manella. I'm a longtime engineer on the Spring team and the lucky person to be your MC for this morning. As we get started, be sure to participate in the conversation by going on Slack at spring1.slack.com. I can't think of a better way to start off Spring One than to learn about what is Spring with Glenn Renfro.
Well, hello, Spring One. I am so glad to see y'all here. Well, this talk is about what is spring. So you're saying, what are we looking for here? And the goal of this talk is if it's been a long time since you've actually played with Spring, you want to kind of know a little bit what's new going on, this talk is for you. If you said, I have never touched Spring before in my entire life, what is it? This talk is for you. If you're kind of saying, I need a kind of a place to maybe help me guide me to see what new projects are new, this talk will be helpful to you. But before we get too much further, I have to click the right screen. There we go, yay! And before we can kick off anywhere, we have to have our attorneys give us something, right? So in this case, we have our forward-looking statements. If you want to take a screenshot of this and read it at your leisure, you can, or you can wait till the end of my presentation. I will share you a link to these slides and you can read it then. But I think it is time for us to get started. Well, who is this loud person talking to you right now? Well, my name is Glenn Renfro. I am one of the engineers at VMware. I work on the Spring suite of projects. Specifically, I work on Spring Cloud Data Flow, Spring Tasks, Spring Batch, and anywhere else they need me. In my copious free time when I'm not doing that, I'm out kayaking or I'm working in my garden. And yes, it is true, plants like technical podcasts. So when you're planting, listen to your favorite tech podcast because they like it. Well, maybe not, but mine do. And when I'm not doing that, I'm also on the board of directors for the Atlanta Java Users Group, and which means I'm on the board of directors for DevNexus, one of the largest Java conferences in the US. And the good thing about this is it's all community driven, right? So with that conversation, let's begin looking at what does the Java community feel, or how does it feel about Spring? Jurgen kind of brought this in, but I'm going to take a different tact. In SNCC's 2021 Java Ecosystem Report, they say that it is still a Spring-dominated world with over half of the market using Spring Boot and another third using Spring MVC, as we can see in this chart. Now, keep in mind that if you don't know what Spring Boot is or Spring MVC, don't worry, we'll give you a primer on it. So that is what's cool about it. Now, you're saying, is Spring being used a lot? And the answer is yes. Hundreds of millions of Maven downloads for Spring every month, and we have seen a 62% year-over-year increase. So I think Spring is being used by a lot of Java developers out there, or Kotlin developers, right? So let's keep that going. Now, one thing is to pull it down, but do people really kind of like it? Well, if you look at the star count for Spring Boot, it's now 56,900 stars. I had to update the slide today because the last time when I started this presentation, and updated it a few weeks ago, it was like I forgot how much lower. And it's like, man, you just see it keep increasing. And I'm like, wow, people really love Spring Boot. I do, but I didn't know other people liked it as much as I did, or do, I should say. So now we've kind of got past the numbers. We know how the community feels about it and how many people are using it. So what is Spring? Well, I went to my friend and Spring Boot lead, Phil, and I said, Phil Webb, and I said, Phil, how would you describe Spring? Well, I didn't really hit him up. I looked at one of his talks. So in one of his talks, he put it the best I ever heard. He said, Spring is an integration framework designed to take lots of different technologies and allow you to combine them in ways that feel natural. It gives you a consistent programming model. What's important about those are two things. It's a natural, let's go back one, oops, not forward, back, Lynn, back. It gives you ways that feel natural, right? And then consistent. So it feels natural and gives you that consistent model. So no matter if I'm pulling in Kafka or Cassandra against the Spring framework, Spring Boot, the way in which I use them has this consistent feel no matter what new third-party technology or new style of development. Spring gives us that ability to have that natural feel. And again, that consistency. So that helps you with your learning curve, right? So the next question is, where did all this get started? Well, there were two folks that kind of kicked off the Spring ecosystem. The first was Rod Johnson, and the other was Jürgen Holler. Well, if you look at Jürgen Holler, we heard from him earlier, but if you look on Josh's desk at the kind of the right side for us, you're going to see a bobblehead of Rod Johnson. So if you look at the bobblehead, that's who it is. But what we want to look at here is how they got started. So basically, what they were doing at the time, back in 2002, they were working with a lot of companies. They were consultants, and they said, we keep hitting these consistent issues. So they created a framework on how to improve the performance of developing applications. And what the next thing that happened is they found it to be successful, and Rod wrote a book. Now, mind this is 2002, so go back into our Wayback Machine, and we can say that the book's title was J2EE Design and Development. And then and it was a hugely popular book. And then they took that framework, and from that they were created, and they created the Spring framework. The foundation pieces of the Spring framework. Well, if I can get there, there we go. Come on, you can do it, app. Okay, come on, you can do it. There we go. Took a second. Is inversion of control and dependency injection. So what are these things? Well, inversion of control, basically. So back in 2002, when we would write apps, we had to write the app. We had to write the control flow of how that application would flow to capture all the events, do all the work, like a web application, right? And they said, what if we could take and allow you to put in a dependency, and this framework would give you that flow automatically, and it would call your beans that have the business logic in them at the right time. So what that means is, as a developer, I focus on the business problem, and I can write that code into a class, or like again we say, a bean. And as I write that code in, that's it, I'm done. Then Spring in turn will call that bean at the right time. So if you will, now I can focus on the business problem, and that flow is managed by Spring. It goes with the idiom, don't call us, we'll call you. Meaning I don't have to worry about calling all my beans with all the business logic. All that stuff is done by the Spring framework. The next part really was dependency injection. What does that mean? Well, no bean lives in isolation. I might have a bean that needs a data source, right? Well, how do I inject that data source into my bean? Well, Spring does the following. It will look at like your constructor and say, oh, this class or this bean needs a data source. So it will inject that data source into that constructor. Or you can say, I really don't want it to come to the constructor. I'd rather come in to an attribute in my bean. Spring helps you there. You can annotate your attribute with something called add auto wired, and it will inject that in there. So the injection of the dependencies that your beans or your business logic needs is done by Spring. So Spring takes care of, again, that control flow. It takes care of making sure that all your objects that you need, or your beans you have all the bits that they need, and that they're called at the right time. The next thing they provided was utilities. They said, what kind of tools can we give our developers that will help them save time and not have to worry about doing all this boilerplate coding? Well, they provided those for us. Then they said, well, our developers are going to be writing tests. How can we help them with that? And similarly, they did the same thing. They provided utilities to help us write our tests. And then they gave us a basic suite of database tools, which was pretty awesome. Then they said, there's a ton of people writing web applications out there, and what we want to provide is something to help them write their web applications. Well, a concept came out called MVC. And you're like, well, what's MVC? If you already know what it is, you have a sip of coffee and just wait just one moment so that folks like I who need to know what it is, or maybe we need a common definition, we can at least give that chance out there. So what MVC stands for is Model View Controller. And basically what that does is it separates the concerns to write web-based application. These concerns are the model, the view, and the controller. What do each of these do? Well, the controller is the piece or that separation, or that concern, I should say, that concern that receives a request from the user. It then passes that request to the model. The model then goes out and takes action with it. It might go look up data, it applies its business logic to that data, and when it's complete, it hands that result back to the view. The view in turn transforms that data into something that's useful for the user who requested it, and then the controller sends that result back out. So Spring gives you an implementation of the MVC model. Now, what's also happened is I said, I want to show folks what it would look like if I had to write an MVC from soup to nuts, meaning what would it take to write it? And so I started hitting the internet. And I said, okay, folks, somebody's got to have something out here where they show how they wrote an MVC framework or, if you will, application. And the answer was, I couldn't find one. Long story short was no one writes their own flow like that anymore as far as the MVC. They are like, we use frameworks to do that, frameworks like Spring. So imagine instead of having to write, we know, as I've said, a lot of code to write an application that does this MVC, if I home roll it myself, all I have to do if I'm using the Spring framework is to use 3 small configurations. In this case, you see I have it written as XML because Spring framework at its foundation supports both Java configuration, so I can configure these using Java, or I can use XML. I chose XML because, well, I wanted to show you some goodness that from there, and then I'm going to show you how we can improve that overall in the future. The first is basically our web XML. The second is the beans. What beans do we need for our application to work? And then lastly, the controller, the stuff that actually does that work for us. So now that we have this kind of foundation understanding of what Spring brings us, how it reduces our code, how it allows us to focus on the business problem, what does Spring look like now today, right? This is from again, back in 2002, 2006, right? Well, since then, Spring's grown quite a bit. So much so that Madura, one of our managers and lead developers on the Spring Boot project, is even kind of shocked that Spring has grown that much over these years. We have everything from Spring Data, Spring Cloud, Spring Sessions, Spring Security, Spring Batch. Oh my goodness, the list goes on. And then as we kind of heard today, Spring Native, Spring GraphQL, the list goes on. And you're going, okay, that's a lot. And I'm like, yeah, it is. But what if we could just take and isolate that down? Let's start off with our foundation. Our foundation is Spring Framework. Spring Framework is the foundation for all Spring-based projects. So you get all that dependency injection, that IOC, the version of control, all that comes in with it at the foundation, all the utilities, all that good stuff. But then Spring said, hold on. There's some features we can add that some applications need, but not all of them. We don't want to roll all this in the Spring framework. We'd rather let people add it as they need. And so they created a series of Spring projects that you can add if you need them. For example, Spring Security, right? So Spring Security is a powerful, highly customizable authentication and access control framework. It's the de facto standard for securing all web Spring-based applications. What if I'm writing batch applications or ephemeral applications? So in this case, ephemeral meaning an application wakes up, does something, and terminates. Well, there's a lot of boilerplate code that has to be written. I have to think about transactions. I have to think about how to read the data in and write. And I have to write all that code? Nah, you don't have to write all that code. Spring Batch provides you a series of wonderful builders that simplify your need to write readers, writers, even you can even create steps using these builders that are provided by Spring Batch. It also gives you the transaction support that you can just configure. It also gives you the ability to restart an app if it fails. Oh, we'll talk a little bit more about it later, but lots of power, a lot less coding. Then you say, well, what about enterprise integration patterns? If you remember the big, thick black book that we all have on our desk, it's somewhere around my house somewhere. It's I could know most of them now, but we either got it in college or we got it, when we were working. And this book shows us all these wonderful patterns on how to route our data through our applications, and like things like scatter, gather, taps, routing itself. Well, what Spring did was they said, what if we could take this powerful book, these powerful patterns, and create an implementation for it? That implementation was Spring integration. So if you're looking at implementation for enterprise integration patterns, you found it. Now, we said, okay, Spring gives a base set of tools for accessing databases, but now databases have grown from from LDAP to JDBC to SQL stores to NoSQL stores to graph databases. Oh my gosh, they're out there. But Spring said, what if we could give you again? You know what? I'll tell you what, I'm going to read what we call a project we called Spring Data, and I'm going to read to you what it says its goal is. Let's see if it sounds familiar. Spring Data's mission is to provide a familiar and consistent Spring-based programming model for data access while still retaining the special traits of the underlying data store. So no matter if I am hooking into JPA, LDAP, JDBC, that whole list, as we see up here, Cassandra, Geoda, Solar, I have that same consistent coding model that feels natural and gives me a consistent approach to utilizing all these various types of data stores. But the key to remember is that I still have each one has a powerful underlying infra in it that we can take advantage of. Spring Data gives that to you while reducing your code and giving you a sense of familiarity to access. But then so we have all these wonderful tools out there, but then people started writing a lot of code and it became a little bit more complex. And we started seeing where people were reporting that they were getting collisions where I'm pulling in this third party, this third party app. And so it became a point where they're like, we're getting dependency complications. We don't know what good defaults are. We're kind of guessing here. What are good defaults just to start our apps off with? Well, a person named Dr. David Sire came up with Spring Boot. And with Spring Boot, it said its goal was to allow you to create a standalone production grade Spring-based application that just runs. Spring Boot provides you a set of opinionated starter dependencies that simplify your build configuration. So no matter if I am pulling in, like I talked about that Spring Kafka, I am pulling in Spring Data Cassandra, whether I am pulling in maybe even AMQP, right, and pulling all this stuff together into this application. If I use these starters, I don't have to worry about dependency collisions. And then what it also does is it gives us a good set of defaults that I can say out of the box, this will work for a kickoff point of view, or to, again, get me ready to get to production. And then I began my testing and all that, and then I can tweak it from there. What's good about what Spring Boot does is it does this without having to do any code generation. I don't have to go through and look at all the code it generated for me. It's done that all for me already. I don't have to worry about doing that. It says, I give you the tools that you need to quickly write your code that you need to write. And you say, well, sometimes Spring Boot may put in those defaults that I don't need, or I don't want to quite have it work this way. That's fine. Spring Boot will easily move out of your way so you can do what you want to do. Again, that magic of not having to deal with code generation. And all this comes available to you right out of the box. So let's give a sample of what Spring Boot does. Again, it gives you kind of that opinionated view of framework. It says, for example, we're going to want to write in a few minutes a Spring MVC app, right? And we show you that this code that we had to here was really a lot smaller than what I have to write if I was home rolling it, right? Or doing it, just writing it from scratch. What if Spring Boot could change this code that we see here to that? All I have to do is add a dependency and write this little controller right here, and I'm done. To do the same thing we saw back over there. Isn't that pretty cool? Well, I'm going to demo that to you in a few minutes. But I need to cover a couple more things. First off, our apps do not live in isolation. We were talking about at the keynote, or AJ was talking about the keynote. We've got microservices. Applications don't live in isolation, right? They live in an ecosystem of other applications. Whether I am writing microservices or something called a monolith, as you know, as I write these, they're going to be communicating with other apps in our ecosystem, and these apps are going to be in the cloud, on-prem, a blended of on-cloud and on-prem, and also what, across cloud platforms, because I may have more than one cloud platform, right? So in order to do this, we need some special tooling to allow our apps to work in a distributed environment. Well, that's where Spring Cloud comes in. Spring Cloud provides tools for developers to quickly build some of those common patterns for distributed systems, right? Like configuration management, service discovery, circuit breakers, intelligent routing, and the list goes on and on and on. So whether you need to, you are working with something like, I need to be able to create data pipelines of streaming data through a messaging framework. I'm going to use something like Spring Cloud Stream. Or, Glenn, I'm receiving, I need to have something that can route my API requests to the right to the right service that can handle that. We have Spring Cloud Gateway. If you're writing batch applications that are going to be deployed to the cloud and they need to be good citizens in the cloud, you have Spring Cloud Task. We can go on and on and on about all the things that Spring Cloud can help you with. But we're going to save a little bit of that for later. But going back to the last step, we're down to the home stretch on this guide right here. What if I am creating those data pipelines, right? Where I am taking in data from anywhere from like a social media or from IoT devices, and I need to be able to handle those events as soon as they occur, but I cannot afford to lose that data that I'm receiving. I need to be able to get that data, process the data, put it in some kind of messaging framework so that it can be delivered to the right services that can actually take advantage of it. This messaging framework may be Kafka, Kinesis, Google Pubs, AMQP, you name it, Azure messaging service, right? How can I take and be able to create this pipeline without writing a lot of code? Well, Spring Cloud Stream allows us to do that. But how can I orchestrate all these streams, right? I'm not just going to have one stream. I'm going to have thousands of streams or hundreds of streams. Spring Cloud Dataflow helps you orchestrate these streams or pipelines. Spring Cloud Dataflow also allows you to orchestrate the launching of your batch applications in a cloud platform and orchestrates that for you. So you don't have to worry about that. And we're going to talk a little bit more about how it does that. Man, I'm going to talk a lot today, aren't I? But before I go, we mentioned reactive coding in the keynote from Jurgen. So if I want to write imperatively or reactively, Spring is there for you, because if you look at the latest icon I added, Spring Framework works directly with Spring, or works directly with the Reactor project. So every project from Spring Framework up, or I should say most projects from Spring Framework up, you can write imperatively or you can write reactively. It's up to you. Or if you're blending it, it's up to you. Spring is there to help you. Well, no presentation I do is done until I give you a demo. I like to code, even though I cheat a little bit when I'm doing live coding. So the question is, I'm going to write the demo, but where do I start? And dang it, Josh took my thunder because I stole his thunder. What's the second best place to go on the internet? It's start.spring.io. And let's give you a quick tour of what that looks like. And what's the first best place to go on the internet, as Josh Long would say? It's production. Well, let's start off writing our application. So the first thing I'm going to do is I am going to go to my browser, and we will put in the magic start.spring.io. Now from start.spring.io, I can create a Maven project or a Gradle project. I'm going to choose Maven. I can choose the language I want. Basically what Spring Initializer does is it will generate the foundation project, which I'm going to be working on. I guess I should have said that to start. But it allows me to check what project type it is. I can select what language I want to use, like Java, Kotlin, or Groovy. It allows me to pick which boot version I want. I'm going to use the latest release, or GA, which is 2.5.4. I can choose whether I want a jar or war. I'm going to select jar. I can choose Java 8, 11, or 16. We're going to choose 11. And soon that will be 17, as we heard. Woohoo! I can't wait. And then we're going to go ahead and start. I'm going to set my group to io.spring. I'm going to set my artifact to demo S1. I think I'll go ahead and call it S1A just for a hoot. And then I need to add my dependencies. What dependencies do I need for a web-based application? Well, in this case, I have a whole list of starters I can choose from. If I was writing a Spring Batch app, I could type in batch. If I was writing a GraphQL app, I can write, I think it's, I forgot what that is. But if I wanted a stream app, I can do stream. And you can see I could put in a Kafka or Spring Cloud Stream Kafka application. But in this case, I'm writing a web app, Spring Web. And now I can create a basic Spring MVC app. Now I'm going to generate our project. And you see that it downloaded a zip file for me. I'm going to unzip that file. And from there, what we're going to do is we're going to open up our IDE. And I'm going to open that application that project it created for me. I'm going to go to downloads. Come on, downloads. Hey, come on, I'm zooming here. Yeah, okay. Uh-oh, I've gotten a beach ball of happiness here. What happened? No. Okay, so when we get the beach ball of happiness, we're going to force quit. Goodbye, IDE. And we're going to restart our IDE. Sorry about this, folks. Things happen during demos, don't they? And let's see, are we starting? Yay, we're starting. So this time we're going to go back. We're going to go back and open. There we go. We're going to re-drill back into downloads. We're going to do demo 1A. We'll open that. And it says, as you can tell, it's a first time opening. It says, do you trust this project? I hope so. I created it. So in this case, we're going to go ahead and open my app and let the IDE kick in really quick. I said really quick. Maybe it won't be really quick. There we go. And it's doing all the good dependency magic here. And there we go. As you can see, I'm looking over the side because I've got the screen right here and my camera is right here. So in this case, we see that demo S1A is ready. And we can see that it provides us the foundation of project, including the POM file, right? So we can look at the POM file and we can see that it gave us the starter web, right? We created a parent. This is going to be our Spring Boot application, Java 11. It's going to use a web dependency, even gives us a little testing dependency here. So we see that we are ready to rock and create our first Spring Boot application. In that case, we will go open our our demo S1A app. And this is all the code there is. Remember I said there's no code generation? The only code that we provide here is what? Our main app. So with that being said, what I'm going to do is cheat a little bit since we lost a little bit of time on getting started here. I would normally like to try to code this out, but my coding is bad. And when I'm doing live coding, I should say live coding, my coding is good. Just coding when I'm going live is really bad. And what we're going to do is we're going to say REST controller. And what we have just added is what? Our controller. This is all the code I have to write right here. So from ground up, I now have a basic Spring Boot application that is a MVC. And I'm going to change this to Hello Spring 1. Okay. Now what we're going to do is I'm going to go to my terminal. And I know this might be a little hard to see, but I'm at the bottom, I'm saying Maven clean package. We're going to build our project. We see that it's executing a test, which is cool. I didn't have to write the basic test. It did that for me. And now I'm going to launch it. Now java-jar target. If I could type Spring, there we go, and demo 1. And we're going to launch our app. Now what's going to happen is Spring Boot's going to start up. It's going to have, it has embedded Tomcat in it when I bring in the Spring Web native dependency. And I've got a homework assignment for y'all that we're going to ask you at the end of the presentation. With having Zoom and all this stuff running on my machine, it took 2 seconds for this app to kick off and get started. I need for y'all to remember 2 seconds, okay? Because I will forget. And we're going to go back here and we're going to take the result, look at the results of our application. And we look at, and if we buy out of the box, all Spring Boot apps start off at localhost port 8080. And we had the endpoint of hello, and we can see that it produced hello Spring One. So within about a few minutes, barring IDE hiccup and my overpowering voice, we were able to create an app in just a few minutes. Now, what we're going is we're going to kick back off and not start from the beginning. Oh my goodness, this is like I didn't practice this at all, was it, folks? There we go. And we are going to go back to here. And what we're going to do is I want to suggest to you, if you're interested in learning more about Spring Boot, please join us for the production boost, which is tomorrow at 11 a.m. You can learn more about Spring Boot and how to get that production boost. If you're looking at a way in which I can write Spring Boot applications more efficiently via my IDE, feel free to jump on the Spring tooling for the masses tomorrow at 11:35 a.m. All my dates on my presentation are Eastern Standard Time, okay? So just giving you a heads up. Now, to take the next step, what we want to also be able to do is look at, all right, so I see we have all these projects. I kind of got an idea of the grouping of projects. If I have a specific business problem or specific software goal, what Spring projects can help me with that software goal? Well, let's get started on that. Well, the first one is let's go back to our original example, which is the, just a basic web application. Now, in my web app, it missed a few things, right? The first is I didn't secure it, right? We want to be able to have security as one of our first and primary goals when we're writing our application. What do we use for our security? In this case, we're going to use a project called Spring Security. And Spring Security is, if you want to think of it this way, is when it's time for me to write my web app. Spring Security supports many industry standard authentication protocols, including SAML, OAuth, and LDAP. And it also gives you protection from top OAuth type attacks like session fixation, clickjacking, cross-site request forgery, and way more. So when it's time for me to secure my applications, use Spring Security. Oops. The next is how can I get access to data, again, in a consistent, easy way, a smooth way to be able to utilize all of Spring, or the Spring way of development. Again, it's natural and consistent. I'm going to use a project called Spring Data. And Spring Data helps developers connect to their web applications to a number of data source. It supports relational, non-relational databases, MapReduce frameworks, and cloud-based data services. Yes, so if you're hooking into a cloud-based data source, Spring Data can help you with that as well, on top of all the other ones we talked about before. Now, like we said, once our app is in production, how can we observe it? How can we monitor it? Well, through Spring Boot, out of the box, we have integration to a project called Micrometer that captures metrics. And these metrics can be stored to a time series DB or to something like Tanzu observability. So all this stuff comes to you from Spring and increases your ability to write effective code and do so more efficiently. So if you want to learn more or have a kind of a primer to what Spring Security can do for you, Spring Security 5.5 from Taxi to Takeoff is today at 4 o'clock Eastern Time. Spring Data Guide to Persistence, a great kickoff for Spring Data as well. That's tomorrow, September 2nd at 10:05 a.m. And you have a talk on tracing issues for you in your application if you're looking more into how to track how your apps are behaving, how they're behaving in the ecosystem. September 2nd, tomorrow at 1:05, Martine and Jonathan will be giving a talk on that. And a hint, please catch tomorrow's kickoff because Martine, Jonathan are going to have a great reveal. They're going to talk about a new project we're going to have that concerns observability. So hint, catch that. Now, I would be greatly remiss if I didn't talk about Spring GraphQL. Spring has worked with the GraphQL Java contributors to create a de facto easy way to be able to integrate GraphQL into your ecosystem. So if you don't know what GraphQL is, it's relatively new, but it's a well-established alternative to REST for exposing web APIs and that is rapidly becoming a popular choice for web and mobile clients due to its ease of use and degree of control. If you want to learn more about that, please join us for the Spring GraphQL talk today at 11:05 a.m. Now, there's two words that all presentations have to have these days, it feels like, at least the ones I present. One is microservices. And so we have a common definition of what microservices are. Microservices are a modern approach to software whereby application code is delivered in a small, manageable pieces independent of others. We can think of it this way. Traditionally we've written monoliths, right? And our monolith applications did several things. I'm going to give you an example of an invoice application. So let's say I have an invoice application that has three primary goals. The first goal is to capture the invoice and save it. The second goal, price that invoice. The third goal is to write out that bill. Now, let's say in our invoicing application, the pricing takes a long time, right? And so we have to horizontally scale our invoice application. Well, while that works, there's some side effects to that. By making 2 or 3 copies of that application, I'm, if you will, increasing the footprint of not only the pricing, but also what? The capture and storing of the invoice and the writing that result out to writing out the bill, or sending out the bills, right? What if we were to split it into its separate concerns, right? And we would have an invoice app that captures the invoice and saves it, a pricing app that prices, and then the third, the app that sends out the bill. Now what happens is if we know now that the pricing takes a lot of time, we can have one instance of the invoicing, one instance of the bill, but the pricing we can bump up and horizontally scale that as we need. But also it gives us another advantage. If we need to update the pricing, we don't have to update the entire application. We just have to update what? The pricing component. So we see the strengths of microservices. But Spring provides you a lot of tooling to do with your microservice development. We'll talk about that. But if you are writing monoliths, that is fantastic. Spring supports you there. Whether you're writing monoliths or microservices, we are there for you. But going back to the microservice conversation, with microservices, to write them, you have to be able to have certain rules that we apply so you write good microservices, and it's called the 12 factors. Some of these 12 factors include external configuration, statelessness, logging, connecting to backing services, and in order to have a real microservice, you have to follow these 12 factors. Now, when I deploy my apps to some cloud providers, they give me some of those services. Some of them don't. Sometimes I want to be able to have more power of how I handle some of those things that I need to meet that 12-factor requirement. So that's where Spring Cloud comes in. So Spring Cloud provides you those services to write successful applications in a distributed environment, and many of those are what? Microservices. So whether you are needing a service registry, Spring Cloud provides that for you. If you need a config server for your external configuration, Spring Cloud provides that for you. Something that's not of a part of the 12 factor, but is just as important, is the ability to know how my messages are going from service to service to service, because sometimes we detect that there's a problem in how messaging is being transferred between various services. So we have a project called Spring Cloud Sleuth that goes in and allows you to track your messages so you can identify those problem areas. And then what about those cases where I'm receiving IoT, mobile, and browser API requests? How can I fulfill those by knowing how to route that API request to the correct service? Spring Cloud Gateway is there for you. If you want to learn more about this, and if you want to learn more about how to do this using on the Azure framework, Josh Long today at 1:05 is going to give you a discussion on rapid development with Azure Spring Cloud. If you want to learn more about API Gateway, how to, 12:35 today. If you are looking to write resilient, adaptable systems with cloud native APIs, we just missed it because you were listening to me. Well, Don't worry, you can catch it on YouTube. We'll be posting these out to YouTube. But I highly recommend that you stay and watch the sessions live because, as Michael said, you can ask questions live on Slack. And after the call, you can also talk to the speaker on a live Zoom session and feel free to ask questions about their presentation. Now, the second word that all presentations have to have is what? Kubernetes, right? So Kubernetes, if you are interested in learning how we can write, be able to write our applications with Spring Boot and see how Spring Boot helps us write applications deployed to Kubernetes, I ask you to join Dave Sire on the Inner Loop Development Talk. He also gives you some tools so you can be able to deploy your apps a little bit faster so you can see those little wiggles and be able to try stuff and work with stuff. In that case, we missed that one too, but don't worry, it's available on YouTube and we'll be posting those out. Also, if next generation cloud native apps with Spring Cloud and Kubernetes today at 11:05. Now, as we talked about before, we need to be able to create data pipelines, right? We need to be able to receive data, process those data, those events, if you will, and be able to handle those data pipelines via messaging frameworks, like, again, the Kafkas, right? And so what happens, or how can we be able to write these apps, if you will, to hook into these messaging frameworks, if you will, that provide us our foundation for our pipelines, again, without having to write boilerplate code, but rather focus on the business problem. Let me state one problem, and this is coming from my mainframe talk. One of the things that we have is CDC, where I can actually go in and capture events from a mainframe, data source, and they're using a product like the Debezium, where it captures the events from the log of a database and then sends that data out onto a Kafka messaging framework. But I want to write two apps. I want to be able to write an app that captures that data, filters it, and transforms it, and then once it's done, send that off downline to other apps that can take advantage of it. In this case, like we see here, update a database. How can we do that where I can focus on the business problem without having to worry about all that boilerplate code to hook into Kafka, right? Well, that's where Spring Cloud Stream kicks in. Spring Cloud Stream offers us the ability to hook into these frameworks and focus on just writing functions that on how we want to transform, store, or transform that data, filter that data, enrich that data, focus on that, but hooking into the framework is done by just a series of properties. And also, again, how can I orchestrate that for, how can I orchestrate the deployment of all these streams, including upgrading, rolling back? Spring Cloud Dataflow helps us out with that. If you are interested in this topic, please join us for full stack observability for IoT event streams. And Pinsky will be doing this presentation tomorrow at 3 o'clock. If you want to see another customer example, driving the data pipelines connected for connected vehicles with Spring Cloud Dataflow, tomorrow at 3:35, we also have a great talk on that. Now, we talked about writing functions using Spring Cloud Stream. Well, we also have a project called Spring Cloud Function. And Spring Cloud Function promotes you to be able to write, basically allows you to decouple the development of lifecycle business logic from any specific runtime target so that the same code you write for a function can be used in a web endpoint, a stream processor, a task, or deployed directly to a serverless service provider like Microsoft Azure, AWS Lambda, and Apache OpenWhisk. And what it does by doing this, you get all those rich features Spring Boot offers, like auto configuration, dependency injection, and metrics. You get all that and be able to focus on a function, and that function can be used in any of these locations. So I write once and use that same function in different locations. It also provides you transparent type conversion. So what type of data I'm coming in, it can do that type conversion for you. And when it's sending the data back out, it can again do that. It does that for you transparently. You can write your functions imperatively or reactively, right? So it goes back to that foundation we were talking about. And if you want to learn more about this, feel free to jump on the Spring Cloud Function, where we were, where we are, and where we're going. And that is tomorrow at 11:05 a.m. Now, a project that I'm really excited about because I work on it sometimes, and also some other projects, but this one I love, and it's called Spring Batch. Spring Batch is an application that or a project that allows you to write boot applications, and with these boot applications, or sorry, allows you to write batch applications, not boot applications, batch applications, and with these batch applications, I don't have to worry about writing a boilerplate code. So if we look at a step, and a step being I have a reader, I have a writer. Now I might want to read from a JDBC source and I want to write out to a flat file. Well, what if I could, instead of me writing all that boilerplate code, I could use a builder to be able to just quickly configure how I want a reader to go read that JDBC source, and similarly write out that flat file. Spring Batch offers that for me. This other thing that Spring Batch does is it provides me the ability to um, be able to restart my application. So if my application fails, let's say out of a 4 million record runs, it fails at record 2 million. It allows me to pick up where I left off. It gives you that ability to configure that. It also gives me the ability to set my transactions by configuration instead of me having to write and try to figure all that out. So when I am writing that step, the only code that is effectively be written beside configuring my reader and my writer is the code that it takes to transform that data. And then I can take a step, that step that's a reader, processor, writer, and I can have multiple steps. And those steps can be run in sequence. I can run them in parallel. All that is done not by me writing a lot of code, but me using builders to configure that. So if you want to learn more about Spring Batch, feel free, or sorry, there's one more thing. The other thing that you want to be able to do is be able to orchestrate those batch apps, because batch apps oftentimes don't just run one, you're running hundreds or thousands. How can you orchestrate the management of running of those hundreds of thousands of jobs? Spring Cloud Data Flow allows you to orchestrate the launching of those apps and gives you a common place to check the status of how those batch apps are running. So if you want to learn more about how to orchestrate your batch applications, feel free to join my talk tomorrow at 5 o'clock, and it's application modernization, migrating mainframe apps to the cloud using Spring. Now, do you remember your homework assignment? How many seconds did it take for us to start our application? I'll give you a hint. 2 seconds, right? Well, now, why do I say that? There's been a heavy duty focus on making our apps take up less memory. And what we mean by that is I want to have the ability to run an app, and instead of taking hundreds of megs of memory, I want to take tens of megs. And when we talk about things like fast, like when we're talking about Spring Cloud Function, putting its apps so that you can run it anywhere you want, whether it's on a stream, a task, or on a fast provider, I need those things, some of those to start really fast in like my hundredths of a second, right? Well, we saw when we were kicking off our app, it took 2 seconds. What if I could compile our Java code to native binary? Well, there's a project out there called Spring Graal, and Spring Graal has a native image compiler. So it will take your your application and compile it to executable. It does that by statically analyzing the compile time and discards all the stuff it says it doesn't need, which is cool, but sometimes it discards a little bit too much. And we're like, okay, we need that stuff back. And what we want to be able to do is to be able to configure that the Graal native compiler to say, I need these other pieces back. And it offers you the ability to write that configuration. But you're like, well, Glenn, I've just written all this code. Now I've got to write configuration to tell Graal native compiler how to pull that stuff back in. No. Spring Native to the rescue. Spring Native provides you the series dependencies, which you can add at start.spring.io by just adding the native starter. And when you build your app and you can specify a -p native, it will first off analyze your project, create those configurations, and then start the native compilation. So you, again, focus on your business problem, not worrying about the compilation. We will probably have some announcements on this project, but remember the 2 seconds. I'm going to step out of my presentation really quick. And I've already done a precompile. Remember the demo S1A. It takes 5 minutes to 6 minutes to compile it from to a binary executable. So I'm going to stop my previous run of the Java version, and I'm going to kick off a natively compiled version of what we just wrote. And we see that it started in 0.15 seconds, a significant increase or decrease in time. And actually, it runs a lot faster, but I've got a lot of stuff running right now on my machine. Now, the other thing is that without any configuration changes before, it took 500 meg for that app to run. Now, it takes less than 30 meg. 500 meg down to 30 meg. So let's hurry up and finish our talk here. We're running a little bit out of time. Play from a current slide. If you want to know more, jump on the Spring Native Talk tomorrow at 10:05 a.m. If you want to learn about how to go serverless in the Spring Framework ecosystem, tomorrow at 2:05, we'll have a talk on that. If you want to know the future, like Jürgen said, join his talk at 5:30, but the future is in the past. We missed it, so catch it on YouTube. I think it's a must watch. If you want to learn more about Spring, please join us on spring.io, where you can learn more about our projects, gather some guides, look at what team members are out there, learn about the community. It's a great place to get kicked off at. If you have a little extra time and you feel free, I highly recommend these 2 talks. Spring for Architects by Nate Shuda. It is, click the link or you can do a screenshot of this. Also, I highly recommend, please join us for a talk, Proactively Designing for Diversity, Equity, and Inclusion. This is a great talk to also join. Folks, thank you for joining me. Here is a link to the PDF for this presentation, and I appreciate y'all joining me.
Glenn, thanks for that huge roadmap of all of the things that are Spring. If you want to learn more about what Glenn talked about, or to just talk to Glenn and ask questions, check out the join the discussion link that's on the screen next to the talk. Is everyone's mind blown yet? If you're interested in Spring and the things that Glenn talked about, be sure to spend the rest of the next 2 days checking out whatever sessions you want. Now, the big question, though, are you intrigued about the next shiny new thing? Trisha G's up next, and she's going to be presenting on exactly that. We're going to take a short break, allow everybody to refill their favorite caffeinated beverage, and we'll see you at 11:05 Eastern.